Hello. Okay, I'm going to be walking you through my Python exercises for this week. So here we go. Um, okay. Exercise one, we were asked to create a basic portfolio tracker, store stock symbols, quantities, and lists, create a list of stock prices and calculate total value, use list comprehension to calculate position values. So here's the code. It's a short one. So up here, we are defining the portfolio information. Right here is our tickers. Here's our quantities of each, and then the prices of each um, stock. So on the next block, we are calculating the position values using list comprehension and multiplying each quantity by its corresponding price. So basically just finding how much of the value, how much of value of each stock we have, and then we are calculating the value of the portfolio. So just sum up all the position values to get the value of your portfolio. And then we are getting the output of the results. So stock symbols. So we're just printing stock symbols, quantities, prices, position values, and total portfolio value. So here I'll run the code. As you can see, quantities, it just shows right up here, kind of outputs this information back in, and then the total portfolio is $41,900. For exercise two, we were asked to implement a simple moving average calculator, creating a list of historical prices, a 5-day and 20-day moving averages, and generate signals when short MA crosses long MA. So here is a sample list of historical prices with fluctuations. Um, and then we are defining simple moving average price. As you can see, we compute the simple average SMA for a given window, returns list. So here's the formula to do all that. Then we are calculating a 5-day and 20-day SMAs. So the SMA 5 is basically, here's the formula, and we're just plugging in 5 or 20 depending on if we're looking at a 5-day or a 20-day. Here is where we're printing the information. Up here it just kind of explains generating signals based on crossover 5-day and 20-day SMAs. A buy signal is generated when the 5-day SMA crosses above the 20-day SMA, vice versa. For sell signal, and then since the SMA lists start at different indices, SMA 5 at index 4 corresponding day 5 in the original day, SMA 20 starts at index 19 corresponding to day 20 in the original data. We use a different offset to align these indices. So 20 minus 5, so the offset is 15. Loop over days where both the SMAs are available. So here is what we're doing there. Um, and then if previous SMAs are less than previous SMA 5, which is these are outputs that we got from the formulas, is greater than or less than. This is where you display your buy signal. If the SMA 5 is greater than the SMA 20 sell signal, SMA 5 is less than current SMA sell signal, as you can see. So we'll go ahead and run this code. As you can see, it's working as functioned. Here are all the 5-day SMAs and the 20-day SMAs, and then here are all the hold and buy signals. So for exercise 3, we were told to create a bond calculator that stores bond details, face value, coupon, maturity, and nested list, calculate yield to maturity, and compare multiple bonds using list operations. So looking at this code, We're approximating the yield to maturity for a coupon bond using the bisection method. The bond pricing formula is displayed right here. The function that finds the yield such that computed price matches the given market price. So lower's 0, upper's 1, for 0 to 100%. So mid is upper plus lower divided by 2. So they calculate the present value of the cash flows of the yield at mid. PV equals sum coupon over 1 plus mid times time. Here, this is just the formula for that for present value. And if the difference is within tolerance, return mid as the yield. So that's the formula of that function. So basically, it's kind of looking at these, it's going to tell us what we're doing in each block. So because the bond price is decreasing function of the yield, the computed PV is higher than the price, the yield is too low. You can see. And then here is the defining the bond as nested list and just some example numbers. So calculate year to maturity, print yield to maturity for each bond, compare, contrast, look for example, identify bond with the highest yield to maturity. We're going to run it on one. So as you can see, the code tells us that bond 2 has the highest yield to maturity at 6.72% over the other two bonds. Next example, we are told to build a price analyzer, create a NumPy array of daily prices, calculate daily, weekly, monthly returns, find the highest, lowest, and their positions. So first thing we do is import NumPy as MP, and then we're taking a sample of NumPy daily prices. As you can see here are daily prices, and we're calculating daily returns as a percentage change. So this is the formula for that, and then we're printing the daily returns. Calculating weekly returns using a 7-day interval. Note this loop from index 0 to lim prices uh, there. So this is where we are going in and calculating the weekly returns in this work right here. So then right below it, this is where we're calculating the monthly returns, printing monthly returns. And then this block is where we are finding the highest and lowest prices for their positions, as you can see right here. Let's see max and min, and that's what we're going to look at. And then this is where we print our final answer that we're looking for. So as you can see here, all the prices, or I think this is all the change, daily returns, and then here's the weekly returns, monthly returns, highest price 159 at position 59, lowest price 100 at position 0. Example 5, implement a simple asset allocation tool, store the current and target allocations in arrays, calculate allocation differences, determine rebalancing needs. So we imported NumPy as MP, and then we define uh, asset names for clarity right here. So stocks, bonds, real estate, cash, just kind of defining the asset classes. Uh, and then here's our current allocations of what, how weighted our portfolio is of each class. And then target allocations is how much we want to be weighted for each asset class. So here we are looking at the allocation differences. Positive means underweighted, buy more. Negative means overweighted, so sell some. And then we are printing allocation balance needs. And then here's kind of the work that we are looking for. I'm going to go ahead and run the code. So it's increase allocation stocks by 10%. See, it's kind of fixing to get to where our target allocation is. And finally, for example 6, we were told to create a basic risk calculator, store historical returns in NumPy arrays, calculate correlation between assets, and compute portfolio volatility. So import NumPy as an MP. Uh, so some sample historical returns are right here. So for asset 1, 2, and 3. So here we're going to calculate the correlation matrix between assets, and each entry I, comma j shows the correlation between assets I and j. Here's the correlation matrix, and that's what we're going to be printing. Here's the formula right there. And then calculating the covariance matrix of each return, covariance, NP, historical returns. Find portfolio weights, for example, equal weighting. Right here, it's equal weighted. And then we are computing the portfolio variance using the formula right here below. And then we're calculating the volatility right here below. Here, I'll go ahead and run the code. And here's the correlation matrix, here's the covariance matrix, and here's the volatility. Thank you for watching. Have a good evening.